Okay, preview for quadrilateral 6-5. What's the most specific name for this figure? This one doesn't have right angles in the corners. And it is also a quadrilateral, okay? But the most specific we can say is the parallelogram. The second one, what's the most specific way we can name it? That's rectangle. Okay, now, what do I mean by this? Well, there's a hierarchy that we just looked at. All of these in this whole big box are parallelograms. I mean, quadrilaterals, excuse me, quadrilaterals. And then they're all just four-sided figures. Some of them are strange little shapes. And then you've got your parallelograms here. All right, rectangles are parallelograms, so are rhombi and squares. Squares can be rhombi and are rhombi and they are rectangles. Some rhombi are squares. Some rectangles are squares. But all squares are rectangles and rhombi and parallelograms and quadrilaterals. Okay, square has a lot of names. The most specific name is a square, if it's a square. Okay, so what I was just saying is, what's the most specific name we can name these figures that we're looking at? The most specific name for this one is, right, it's a rectangle because of the right angles, and it has 4 equal sides, which makes it a rhombus. But the most specific name is a square. I only have one way to name this baby. It's only got 4 sides. So quadrilateral, that's all I can call it. When I go to the next section, be careful what it's asking you for. It says state all possible names for a figure. So if it has 4 sides, it's a quadrilateral. Okay, so both of these are quadrilaterals. Okay, now I'm not looking for just the most specific. All right, so I got to have quadrilateral. What else is this thing? Okay, it's got 4 equal sides, so yeah, it's a rhombus, but before a rhombus, we could have called it a parallelogram because a rhombus is a parallelogram. Now, I'm not going to worry about what order these are in as long as you have all 3. Okay, so you need all 3 of those answers because it can be called all of those things. This one has a list. It's a quadrilateral. Does it have opposite sides parallel? Yes, so it's a parallelogram. It also has right angles, therefore it's a rectangle. Oops, I spelled that messed up. Oops. I messed up my spelling of rectangle. Excuse me, let me fix that. Rectangle. And then because it has 4 congruent sides, it's a rhombus. And then because it has both a rectangle and a rhombus, it's also called a square. Okay, so the square can be called all of those things. Do we follow? So it sticks, like, see, if you look back at that picture, the square is all of these guys right here. He's attached to them. The rectangle is parallelogram and then quadrilateral. Okay, and then we got the kite stuff on the other side. So, solve for each. This figure is a parallelogram. In a parallelogram, the property we are going to use for this problem is that opposite angles are congruent. So, 13x plus 6 is equal to 110 degrees. We subtract 6, so we get 104. Divide by 13. Is that 8, right? All right, so x is 8. On number 8, those angles are not congruent. So please don't set them equal. What do? Okay, they are in between parallel lines along one side of a transversal. They are consecutive supplementary. So 10x plus 20 plus 2x plus 16 equals 180. Okay. Now, if someone chose to write opposite angles are congruent, and then 4 angles would add up to 360, not 180, but we're only going to do 2. So I got 12x plus 36 equals 180. By simplifying and combining like terms, I subtract 36 and get from both sides, and I get 144 on the right and 12x on the left. Divide by 12, and I have find out that x is 12. Okay. Number 9, this is a property that is not about angles. The opposite sides of a parallelogram are congruent. So 2x minus 17 is equal to 7. We would add 17. 2 times x is 24. Dividing by 2 gives us x is 12. Okay, what am I going to do with number 10? Pretend the diagonal isn't drawn. Then this corner would just be 71 plus 9x, right? What are these to each other? Angles x and that one by the y. They are supplementary, okay? Now, another way to think about it, in case someone was looking at this and they thought about this transversal, you could have put 9x on the alternate side, alternate interior angles congruent. And then these 3 angles are in a triangle, which would add up to 180. So no matter what you do, 8x plus 7 plus 71 plus 9x adds up to 180. 8x and 9x, 17x. 7 plus 71 is 78. Combine your like terms. Subtract 78 from both sides. We get 17x is 102. And then we're going to divide by 17 and find out x is 6. Okay, we're dealing with the properties of parallelograms right now. X to J is 21. The diagonals, we should remember, bisect one another. So if that's 21, x to L is 21 as well. But they said LJ, that's the whole diagonal, 3x plus 15. It's going to equal not just 21, but 21 plus 21, which is 42. So be careful. Subtract 15 from both sides. We get 3 times x is 27. Divide by 3 and get 9. Okay? Next. If we don't need this, does anybody still need this? I know I do my algebra kind of quick here. Find the measure of one interior angle in each polygon. You have to flip the paper, don't you? Oh, you already did. Okay. One interior angle. This has 24 sides. First, you need to get the sum of the angles. The sum of the angles is 180 times the number of sides, 24 minus 2. You have that formula in your ISN. 180 times 22 gives me a rather large number, 3,000, what is it? All right. So that's the sum of all the angles inside that thing. You want one angle. So what do you need to do to the sum of all the angles? Divide it by the 24. Okay. And that will give you one angle. And this was on the last quiz. Some of you did quite well with that part. You put the sum in one blank, you put the angle in the next, which is what I hinted for. This is 165 degrees, right? All right, that's it. Done. All right, so each angle of that polygon would be 165 degrees. It's very, very big. All right, it says the interior angle sum. Oh, find the interior angle sum. All you want is the sum. So don't divide. Multiply 180 times the number of sides of an octagon is 8 minus 2. So I got 180 times 6. 600 plus 480 be 1,080 degrees. That's all they want. Read carefully. Do not divide it. The next one is I really want to talk to you about because of that last quiz. And when you see your quizzes, you're going to realize why I mentioned this. But some of you understood it and remembered. One exterior angle. Every single polygon in this world has the same sum on the exterior angles. What does the total always? All right, 360. How many sides does a dodecagon have? 12. All right, that's as high as we went. I didn't even make you do 11 on decagon. Decagon is 10. All right, dodecagon's 12. All right, so if I got 12 sides and I know the exterior angles add up to 360, I need to take 360 and divide it by the number of angles, because it should have said that regular polygon, by the way, has to be regular for them to all be equal. So it said find the measure of 1. On this last quiz, I wrote down sum. What's the sum of the angles? 360, and you were supposed to write that 3 different times on 3 problems. And then it said to do 1 angle, and you would divide and get 30 degrees. I had all kinds of weird stuff on that quiz. Hopefully it wasn't yours. 15, find the midpoint of the line segment. You should know midpoint formula as x plus x divided by 2, y plus y divided by 2. And you need to make sure you do the additions before you divide. Add before dividing. So we take -1 plus -9 and divide by 2. We take 5 plus 7 divide by 2. So the midpoint of this would be -10 divided by 2 and 12 divided by 2. Simplify that. -5, 6. Okay. No one should miss this formula. We've done it so many times. It's also on the wall of the classroom, right up there if you need to look at it. We should know it by now. 16, the distance and slope. Now, you can do your distance formula. I'm thinking I'm going to do the slope first. Slope is y2 minus y1 over x2 minus x1. Should have that one memorized. I'm going to do -5 minus -4. And 3 minus 0. -5 minus -4 would give me -1 on top. And 3 minus 0 give me 3 on the bottom. Okay. The distance formula is the square root of. You're supposed to subtract your x's and square the results. You're supposed to subtract your y's and square the results. Well, didn't we just subtract our x's? We already did this, right? And we got 3. So let's use it. Square root of 3 squared plus, we already subtracted our y's too. We did this part. We got -1. So use it. 3 squared plus -1 squared. That would be the square root. And here's where you guys are screwing up, is right here. When you calculate the square of a negative, 3 squared is 9. What is -1 squared? Is it positive or negative? Always positive. And some of you type it, and you type it without the parentheses, and you end up getting 8 instead of what you should be getting here, which is 10. Square root of 10. Okay? So just be careful. I mean, I've had so many of you subtract the numbers correctly, yet you get the wrong answer because of this part right here, not squaring properly. All right, let's go over here. 17, I'm going to do by climbing. I'm going to climb up. Ooh, that was a terrible climb. I went very crooked. Okay, so if I go from this point up to the next point, I went up 1, 2, 3, 4, 5, 6, 7, and I went right 1. So the distance, or that's the slope, up 7, right 1, 7 over 1, which is 7. I can use those numbers to do the distance too. 1 is the change in the x's. 1 squared, the change in the y's, so subtracting the y's, you'd get 7 plus 7 squared. 1 squared plus 7 squared is 1 plus 49, so this is the square root of 50. Okay. Please make sure that when you're doing your quiz that you actually do both distance and slope, especially if I didn't put blanks for them on the quiz. Can't remember if I did. Okay, do both for the last two questions. The quiz is much like this. Let's do it. 5 root 2, if you know how to do it, sure. I'm just not worrying about it right now.